Okay, so 5.7 and 5.8 altogether, future value of investments, present value of investments. Doesn't sound like it'd be confusing, but it is a little bit confusing. So you're going to learn how to calculate the future value of a periodic deposit investment. That means you're making deposits, you know how much the deposit is, but you want to know how much it's going to be in the future, right? You're going to also be able to do that if you just make one deposit and want to know how much that's going to be worth in the future. And then we're also going to be doing calculating how much you need to deposit in order to have a certain value at the end. So what of these, why would we be learning to do this? Because this is going to, I mean, in theory you can use these, and these calculators are on the internet, right? So we are going to learn how to use the formulas. If you ever need to know this information, you go to a financial calculator on the Google or the Chat GPT, and they can do it for you, but what they're going to do is they're going to use these formulas, right? So we're going to learn how to use the formulas in order to help us budget money. We want to save for our college tuition in 3 years. If we want to save to buy a house, it's for a down payment to buy a house in 10 years. Or if you're an old person and you want to, or you're a young person thinking about being an old person and you want to know how much money you need to be depositing in a certain investment, given certain conditions, so you have enough money to retire and can pay your bills, right? So it is really a budgeting thing, right? It could be for fun stuff, it could be for necessities, but how much would you need to deposit so you have a certain amount of money after 10 years? Or if you want to have $10,000 in 10 years, how much do you need to deposit now if you want to make one payment? Or if you want to make payments every month, how much would that payment have to be every month? Does that make sense to everybody? Okay. So we're going to start with a little vocab. Future value of a single deposit. So you're going to deposit one lump sum of money, and the balance at the end after you have calculated its growth, given an interest rate in a certain amount of time, that would be the future value of one deposit, right? Single deposit. Balance an account will grow to when only one deposit is made. So it has to be an interest-earning investment or a growth investment of some sort. So a single deposit means one deposit. A periodic investment means you're going to be making periodic deposits, and it would be the same amount, a recurring deposit. Same amount at the same interval of time. It could be once a year. It could be every month. It could be twice a year, semi-annual, right? So a periodic investment is an investment the same amount at every same period of time. The future value of a periodic deposit investment just means you know how much you're going to be depositing, you know how often you're going to be depositing it, you know the interest rate, and you know how long. How much will it be worth? That would be what will it be worth in the future. Does that help you, Daya? Remind me I can bump up that bottom one if you guys in the back can't see it. Looks like like you're mostly caught up with me. Almost. Brooke, you can't be on that, honey. Where's your Chromebook? Oh, you need to get a charger and charge it. You can't be on that. I'm sorry? I have a charger. All you got to bring up is your student ID or your phone or your keys, something I know you won't forget to bring back my charger. So put your iPod away or your tablet away and get your Chromebook out. Thank you. All right, so this is the formula for the future value of an investment. One of them is for a single deposit. One of them is for a periodic deposit. So that would be a recurring deposit of the same amount for the same period of time. For me, I think they make sense when you kind of think of them as a question. So this formula is going to answer the question, what will be the future value of a single deposit? So that's what this formula tells us. What will be the future value of a single deposit? That's what A is, okay? This formula tells you what will be the value of future value of a periodic deposit. Remember, whatever is over here is what we don't know typically. All of our formulas that we have right now, if we use them, they're solved for the thing. We have a formula already solved for that variable. So if you think about this formula tells you what the future value of a periodic deposit will be. For me personally, that makes more sense. Okay. So looking at the examples, you got to go through and pick out all the parts you need. For this formula, we need to know what A, the ending balance is, T, the principal, or that deposit, the rate. Remember, as a decimal, N is a number of times it's compounded in a year. We've used N a little differently in different formulas. So these formulas, it's how many times it's compounded in 1 year. It's not a fraction unless it's, yeah, I can't imagine when it's going to be a fraction. And then the time. So how do we know what this one is? This says, suppose $600 is deposited into an account every quarter. So you're looking at this period, this statement here, every quarter, each month, every month, quarterly. Those are the things that let you know that this is a periodic deposit. The account earns 5% interest compounded quarterly. We do need to know that. What is the future value of the account after 5 years? So these are the things we need here, right? So we should, without even looking at the formula, what is the future value? So that's going to be the ending balance. So all of our answers looking for, well, not all of them ending balance, but this one it would be. The P is going to be that periodic payment of $600 every quarter, so it's every 3 months, right? But we don't need to know 3 months for this. Our rate, don't forget, you divide that by 100, it would be 0.05. How many times is it compounded in a year quarterly? There's 4 quarters in a dollar, 4 quarters in a year. Okay? Toby, are you following along with that? Okay. And the time is 5 years. So we're plugging it in. We have a periodic deposit, and we want to know the future value of it. So this is the formula we're going to use. So this would be the single deposit. This would be the periodic. Does that make sense to everyone? All right. So now we're going to go to our decimals calculator. And we're going to enter that. And then I'll let you copy it down for mine in a second. But we're going to practice entering it if I can find my Desmos calculator. So everybody get on your Desmos calculator. I gotta clear mine out. Okay. And I don't, I'm not gonna remember now. Let's see this. So I'm gonna have to help me remember what to put in. So here, this is what we're gonna use. So we need our P. So did we do that already? Hold that thought. Yeah, we did that already. All right, so our P is 600, our rate is 0.05, our N is 4, and our T is 5. So we're going to use this formula and plug in. So it's a big fraction, so I'm going to start with a fraction. That's what everyone should be doing right now. Everyone should be doing what I'm doing. In that numerator of that fraction is our principal. Our payment, periodic payment, is $600. You don't have to put parentheses there. I think on the next screen I do. But we do need 2 sets of parentheses here, and we'll wind up having 2 on the right. If you got 2 on the left, you always have to wind up with 2 right ones. Does that make sense to everyone? Okay. So 600, we put 2 parentheses. Our inside parentheses here is what we're putting here. So 1 plus, it's our rate divided by the number of times it's compounded, so we need another fraction. So the rate's 0.05, correct? And it was compounded quarterly, so our N was 4. So I'm going to close those parentheses, so right parentheses. So this is where we are right now. Is everybody with me? You with me, Joseph? Make sense? So now we need our N times our T. So we need an exponent, AB. And we do need parentheses there. So it was 4, I forget how many years. Is it 6 years? 5 years? 5 years. 5 years. Now, make sure you get out of this exponent, so hit your right arrow to get out of that exponent, because if you do -1 right there, it'll be wrong. So you get out of that, and then your minus sign will be back in the middle. -1, and close your parentheses. So I'm comparing, I've got my payment, I've got 2 parentheses, 1 plus my rate divided by my compounding periods, all raised to my number of compounding periods times my time. I remember to get out of my exponent and subtract 1. So now I need a fraction and a fraction, and put a fraction in that denominator. And my rate is 0.05. And so we're putting this exact same thing in. Give you all a second to catch up with me. Dennis, you have too many parentheses, baby. 2 on the left. And that 4 you're entering is going to be an exponent. So you've got to go a to the b power, okay? So go ahead and go all the way back. Keep knocking that off. This one is yours, Dennis. So you see here. So you're right here. Go ahead and erase all of this stuff till you get to here, and put one of your right parentheses in. And then you got to raise to a power before you put your 4 times 5. Does that make sense, buddy? All right, Evans is good. Layla is good. Anybody have questions about how we got here? All right, so this is something you guys, as a group, not one person sitting in this chair necessarily. Joseph, you see where you are right here? That's got to be an exponent, but the -1 can't be. Yeah, 4 times 5, not 4.5, right? 4 times 5. So go ahead and erase that one more time. One more backspace. You did? Okay, now a to the b power. Now, left parentheses, 4 times 5, right parentheses. Right parentheses. Hit enter. Okay, hold on a second. You need another. Is that right? Sorry? Oh, so you got 2 in the front, you got 2 in the right. Oh, no, yours different than mine. I don't. You got it? I think sometimes, Tracy, you just have to start over because it was weird when you tried to backspace. Because I did the same thing. I tried to just edit it, and I don't know if I messed it up or what, but just clear it out and try it again. All right, we're going to do another one, so I'm going to leave you alone for a second. But let's go ahead and put what we're putting in there in our notes. And just for the record, you do not need this first parentheses. You don't need that. You already wrote this in your notes, Brady? Mm-hmm. Okay. We just need 2. So they've got a bracket there. That counts as a parentheses. So the fraction bar is a grouping symbol, and in this decimal calculator, you don't have to have another set there. Right? So this is a bracket. You cannot use the brackets on your keyboard. There are brackets on your keyboard. If you use them, though, it does not recognize them as parentheses or grouping symbols for math. It only recognizes the parentheses. Okay? And so if you didn't get it written down, that's what should be there. Make sure you're paying attention to where it's rounded to. It was an 8 there, right? 787. So this is the decimal place. That's the pennies. We're always rounding to the pennies if it's many. Look to the right. Remember, this stays an 8 or it goes up to a 9. Since this is greater than 5 or greater, that's why it got rounded up to a 9. All right, a few more seconds and we'll move on. I am recording it, so you can always fast forward if you need to, if you don't finish something, that way you can get in as much as possible. Rich and Laura are both 45 years old. Example 2. They open an account with the hope that it will gain enough interest by the time they retire at 65. It says gain enough interest. They don't tell us enough interest for what, but I guess so that they can live and feed themselves and pay for their bills. They deposit $5,000 each year into an account that pays 4.5% interest. So you have to recognize when it says they deposit each year, that tells us it's a periodic deposit. Okay? This is the interest rate compounded annually. So what's their N going to be? How many times will it compound each year? If it compounds annually. 1, right. Now, here's the thing. Where's our time? Where's T? It is 20. How'd you know that, Layla? Very good. They tell you they're 45, and then when they're going to retire at 65. So 65 minus 45. And that gives you the time of 20 years. So they have 20 years, can't type, 20 years to invest this money. All right. So the question is, what is the account balance when they retire? So if we know the payment, we're finding the future value of this periodic payment. We don't know what the future value is. That's what we're looking for. We know the payment's $5,000. We know the rate. Remember, 4.5 divided by 100. Compounding annually means their N is 1 once per year. And for 20 years, this money will be earning interest. So we're going to go through. I'm going to try to edit this formula. I'm comfortable doing that, especially if I double check it, because I can see and make sure that I can go back and make sure I did things right. So my rate is not 5, it's 4 now. My N is 1. Now this only works if you kind of remember where things go. So remember, this is the formula we're plugging in for. This will be the rate, this will be the compounding, the N times T, right? So the beauty of the Decimalist calculator is that you can edit these entries, right? But it only works if you're really paying attention to that. So the rate, the deposit, it's compounded annually, and it's for 20 years. So this and this are always going to be the same, just remember, on this particular formula, that is. And so I'm going to switch that. So the payment, the interest rate, the number of times it's being compounded. Interest rate, number of times it's being compounded. Isaiah, what are you doing, bud? Are you doing it on your calculator? Yeah, I want you to practice that at home. I want you to practice this with us here, and then, like I said, you can do. Okay, as long as we're making sure we're getting here. Did you get 156,587.1139? Perfect. So what's that going to round to? Mm-hmm, 0.11, because this is what we're rounding to. The number to the right is less than 5, so we drop all that off. So this is what you should have plugged in. Oh, I don't know why this is not okay. This is what we should have gotten. So far, so good? Any questions? All right, we're going to skip this one for now and come back if we have time. So now we're going to be talking about, now we're going to know, or we have a goal for our future amount to be. We'll either know what it is, or we'll know what we want to be, and we're trying to figure out what we need to deposit. Okay, so that's what we're talking about here. Present value is the current value of a deposit that is made in the present time. Present value of a single deposit investment. The value for how much a one-time deposit should be at a specific interest rate in order to have a certain amount of money saved for a future savings goal. Retirement accounts are something that quickly comes to mind, but for younger people, saving for a car might come to mind, saving for a down payment for a house, saving for tuition or living expenses while you're in college. Those are things that you might want to be thinking about. So the value for how much a one-time deposit should be at a specific interest rate in order to have a certain amount of money saved for a future savings goal. This is exactly the same thing, really, but it's going to be multiple deposits, or multiple, you could think of them as payments. There really are deposits, though, because you're not buying anything, right? So the value for how much you deposit on a regular periodic basis at a specific interest rate to meet a future goal. Say it again. Nope, it'll be on the recording, so you don't need to take a picture, right? It'll be on the recording. Can you see it better now? Better? You can also move up. We've got a couple of seats empty. If you need to move up, though, we can move you up permanently if you think you're having a hard time seeing from there. Are y'all caught up with me? All right, we're going to move on. If you need me, I can come back later. I'll remember it's going to be in the video on Canvas. Looks weird, but okay. So what is the present value of a single deposit? So that means what do we need to deposit to have this beginning balance here? So what would be the present value? In other words, what payment or what deposit do we need to make one time? Okay? Mr. and Mrs. Johnson know that in 6 years their daughter will attend state college. She will need about $20,000 for the first year's tuition. How much should the Johnsons deposit into an account that yields 5% interest compounded annually in order to reach that amount? So how much should she deposit? That tells us we're looking for one of the formulas that start with a P. Right? We don't know that principal amount. That's what we need to know. In this case, they don't tell us how often it's being deposited, so that's how we know it's a single deposit. All right, so it's a single deposit. Make sure you've made a note of that. So what are some other things that we need to note here? What is the $20,000? So these are the things, if we recognize that we're looking for the payment of a single deposit, these are the things we need to be able to identify. The last couple of problems are A with a question mark. Is A a question mark now, or do we know what it is, or what they want it to be? Yes, A is the $20,000. That is what they want this investment to be worth in 6 years. How much they need to deposit, that's the question mark. So that's how we know we're going to be picking one of the formulas from that says P equals, right? Not A equals. The rate, 0.05 is 5 divided by 100. They should tell us here it's compounded annually. Remember, that's what your N is. And in 6 years is when they want to have this money. So that's what our time is. Any questions? $20,000. So now we're going to go, this is the formula we want to plug it into. We're going to go back here. This is all out the window. We can leave the fraction if we want. $20,000 is what would be their A. That's in the numerator, right? I'm just going to clear all of that out there. So in the denominator, we need 1 plus the rate divided by the number of times it's compounded, all raised to the compounding number times T, right? So we're going to start. We do need parentheses because we're raising all that to a power, 1 plus. This is a fraction, nice little easy fraction button. That rate was 0.05, and it was compounded annually, correct? So, our N was 1. We're going to close that parentheses, the right parentheses, and now it's raised to the N times T power. Hit your A to the B button. The time is 6 times 1. Actually, let's do it the other way. Compounded annually, that's your N, times your T, 6, and close that parentheses. So this is the amount of money they need to deposit right now, and it was in 6 years, that same interest rate compounded when we said it'll be worth $20,000. So they can make $6,000 or almost $5,000, a little over $5,000 just by putting this lump sum in and leaving it alone, right? So that's a pretty good 6 years. You make $5,000. That means it costs them $5,000 less to send their kid to school than it would to send mine to school, because there's no way on God's green earth I could have deposited $15,000 in one sum, right? But if you have the money, then you could do that. So it should look like this in your notes, rounded to the penny. If you did not put that in your notes yet, let's go ahead and put that in your notes. I'm going to give you just a few seconds, remembering that this is going to be in the video. Actually, right now I have the completed notes in there, so you could just scroll through before the end of the day, because I'll probably take it out at the end of the day. I did not mean to put it in there. But the video will be there. Okay, here we go. One more example, single deposit, same formula. For the sake of time, I'm not going to make us put it in the Decimus calculator together. We've done it a couple of times. We should be getting comfortable with that. Amber just graduated from college, and she wants $100,000 in her savings account after 10 years. Doesn't say every 10 years, right? After 10 years. So that's what she wants her ending balance to be. So that's her A, right? She wants it to be $100,000. How much must she deposit? That question tells us which formula to use. How much where'd it go? How much must she deposit in that count? It doesn't say how often she would deposit it, so that means it's a one-time deposit, right? So we want to know what that would be. This interest rate is going to trick you up. Anytime there's an interest rate with a decimal in it, kids want to just leave it at 0.95, but it's not. 0.95 divided by 100, remember, 0.0095. It's compounded daily. So what's our n going to be? How many days are there in a year? Yep, we're assuming a regular year, not a leap year. And the time, 10 years. So we're plugging it into that same formula. That's the numerator. And then the denominator, 1 plus the rate divided by the number of times it's compounded, raised to the number of times it's compounded times the time. So if she deposits almost $91,000 in 10 years, she will have made a little over $9,000. So that's pretty good. That is assuming that she has almost $91,000 somewhere, which I've never had. So. Any questions? All right, so we're going to move on to the next one. Present value of a periodic deposit. You don't need these parentheses. So what is the present value of a periodic deposit? That means what does the deposit need to be? The deposit is the unknown. The periodic deposit is the P. It's the P here, right? That's what that is. So what does an example of that look like? Bob wants $50,000 at the end of 7 years in order to buy a car. If his bank pays 4.2% interest compounded annually, how much must he deposit each year? So they're telling us how often he deposits, so that makes it a periodic deposit. And how much must he deposit? That's our unknown. So we have to use a formula that starts with P equals. So there's several P equals, but at least you know it's not one of the A equals formulas, right? So he wants it to be $50,000, so that's his A. We don't know how much he wants to deposit. That's what we're looking for. That's why we're going to use this formula that is solved for P. We know his rate is 4.2 divided by 100 to get it to a decimal. It says compounded annually. That's one time a year. Remember, these formulas is how many times is it compounded in a year. Annually means 1. And the time is 7 years. not entered one of this, so we're going to enter this in the Desmos together, and then we'll go back and try to squeeze in as many of the other problems as we can. So the formula is A times the rate divided by the number of contacts. We got a big fraction, so the A was $50,000. So $50,000 times the rate divided by the number of compounding periods. So the rate was 0.042. And it was compounded daily, is that correct? Nope, compounded one time. And it's all divided by, so it's a pretty elaborate denominator as well. So it's going to be 2 sets of parentheses. Oh, Lord, what did I do? Oh, nope. Nope. Okay, 2 sets of parentheses here. Oh. Right? 1 plus the rate divided by the compounding period. So 1 plus a fraction. Same as here, 0.042 divided by 1. We've got to raise that to the n times t power. So we're going to do the a to the b. Left parentheses, n1 times t was 7 years. Is that right? 7 years, yes. And here's the thing, remember, get out of that exponent. You got to hit that right arrow. And then it's minus 1. Right arrow minus 1. So $6,292, and remember, this is going to stay a 5 or go up to a 6, and it is going to go up to a 6. If you did not get that, let me know. I need to help you figure out how to get that in the calculator. Any questions? You got it? Did you get it, Kamaya? Did you get it, Tikaya? Did you get it, Puggy? All right. Mary wants to go on a $10,000 vacation in 1 year. She has a bank account that pays 4.25% interest compounded monthly. How much should she deposit each month to meet her goal? So this is what tells us which formula we need. Periodic deposit is unknown. We're using the P equals, the one we just used. We know her ending balance, her A, is what she wants it to be $10,000. That is what we don't know, the P. The rate, 4.25 divided by 100. Compounded monthly, how many times would it be compounded? If it's compounded monthly, what would her N be? Darby, what's the N going to be? Compounded monthly. How many months? Yep, in a year, 12. And then her time is only 1 year. So that's her numerator. 10,000, the rate divided by the number of times it's compounded, and that's the denominator. 1 plus the rate divided by the number of times it's compounded, all to the power of n times 1, and the time is 1. So that would be 817.23. If she deposits 817.23 every month, given this, she should have $10,000 in a year. How much money is she actually depositing? So she'd be depositing $9,806.76. So remember the difference in that and the ending balance to be the amount of interest she earned. And it's free money, so it doesn't seem like a lot, but remember it's free, so why not? Which ones do we not do? Gotta go back to number 3, I think. Do we only skip 1 or 2? Only 1? All right, we got that one. We got that one. Got that one. That's the only one we skipped. Well, we can do that one. We've got 4 minutes. We can do that one if y'all are paying attention to me. If you're not paying attention, I'll let you do it on your own. You want to do it together, or you want to do it on your own? Together? Okay. So Linda and Rob open an online savings account that has a 3.6% annual interest rate and it's compounded monthly. If they deposit $1,200 every month, how much will be in the account after 10 years? So are we looking for the P or are we looking for the A? What'd you say, Uzziah? The A. Yeah, we know the P is $1,200, right? So A is what we're looking for, and we know our P is $1,200 every month. Our rate, we should be getting pretty good at that. 3.6 divided by 100. What is our N going to be? Yes, it's compounded monthly, so it'd be 12. And what is our time going to be? 10. So we look for a formula. So to decide, it's a periodic deposit, $1,200 every month, and we wanted the A. So we got to go back here and be able to pick it out of these formulas, right? So this is a single deposit, so this is the formula we're using. We're looking for A. We know all this other stuff. So we're going to plug into there. The P, the rate, the N times the time minus 1. Remember, no brackets. They use brackets here, and that is a standard way to write this problem. If you, every other grouping symbol would be parentheses or a bracket, but Desmos does not recognize a bracket, so let's use 2 parentheses. Yeah. Is that better? So the rate divided by the N times the T, rate divided by the N. So if they deposit $12,000 every month for 10 years at that interest rate, compounded monthly, they'd have $173,022.87. I know some of you want to use your hand-here calculator, but I'm strongly encouraging you to use this Desmos. We'll have it on the test. It's a lot easier to find your mistakes and compare what you entered to what you should have entered. Don't forget your homework is just 1 through 4. You don't have to do 5 through 8 until Wednesday.